Welcome to Handling Missing Data and Imputing Values. After completing this lesson, we should be able to drop records and fill missing data according to different criteria and drop duplicate records. Data frames have an NA method which provides functionality for working with missing data. It returns an instance of data frame NA functions, which implements three types of methods. Drop methods for dropping rows containing NaN or null values. Fill methods for filling or replacing NaN or null values, and a replace method for replacing values matching specific keys. This is an example of a data frame with missing values. First, I create a data frame with some random values, just like I did in the previous lesson, and name it df. Then I have to set some of its values to NaM, so I have a data frame with missing values. In order to do that, I create two user-defined functions, or UDFs, one to turn values over half into a NaN, named half to NaN, and the other to turn values over 1 into a NaN, named 1 to NaN. If you've never heard of an UDF before, don't worry, they're just like any other function. The difference being that they take a whole data frame column as an input, perform operations over each value inside its column, and output the results as a new data frame column. Okay, now I perform 6 operations on my data frame. I create 2 new columns, NaN uniform and NaN normal, applying my 2 UDFs to the uniform and normal columns. I drop these 2 columns since I do not need them anymore, and finally I renamed my just created NaN uniform and NaN normal to uniform and normal, respectively. The resulting data frame is then assigned dfNaN. This is what dfNaN data frame looks like. Notice that row with ID 1 has missing data in both columns, while the row IDs 2, 3, 7, and 8 have only 1 missing data. Let's start with the drop function from the data frame NaN functions object. As its name states, this function is used for dropping rows containing NaN or null values, according to different criteria. There are several different types of drop available. I can drop rows that do not have a minimum number of non-null columns. I can drop rows that contain at least one null column or all null columns using respectively the any or all keywords. I can specify a subset of columns over which these criteria will be computed, or I can simply call drop without any arguments to drop every single row that contains at least one column with a null value. Let's start by dropping rows by using the min non-nulls argument. In this example, I set the minimum number of columns without null values to be 3. In effect, this is the same as saying that I want to keep rows without any null values on them, since I only have 3 columns. I had NaN values on rows with IDs 1, 2, 3, 7, and 8, so these rows were dropped, and I end up with a data frame like this. Now let's drop rows using the how argument. I will also specify a subset of columns over which this criteria is going to be applied. In this example, I choose to apply it over the 2 columns containing values, uniform and normal. And I set the how argument to all, meaning that I only want to drop rows where all columns, in this case all specified columns, have null values. So the only row with both uniform and normal columns containing null values is the row with ID 1. And that is the row dropped, leaving me with a data frame like this. Here is another example using the how argument, the difference being I'm using any instead of all. So in this case, if there are any null values on the specified columns, the row is going to be dropped. Rows with IDs 1, 2, 3, 7, and 8 had missing data on them, so these rows were dropped and I end up with a data frame like this. What if instead of dropping rows containing null values, I wanted to impute these values? Then I can use the fill function from the data frame NA functions object to replace NaN or null values according to different criteria. There are several different types of fill available. I can fill different values for different columns using a map. I can fill the same value for different columns. And I can fill the same value for all columns of the same type, either string or double. Let's start by filling all double-typed columns in a data frame with 0. In the data frame I created in the beginning of this lesson, I had NaN values in rows with IDs 1, 2, 3, 7, and 8. So these values will be filled with 0, since both columns were double-typed. I end up with a data frame like this. Replacing numeric null values with 0 is quite easy, but not that useful. A much more common operation is to replace null values in a given column with a more meaningful value, say its corresponding mean. So let's compute the mean value for the uniform column and use it as a default value for filling null values in the column. Here I use the combination of filter, group by, and ag functions to get the mean of the column uniform. First, I use filter to get rid of all rows with null values in the column uniform. Then I use group by with nothing within the parentheses to group all the filtered data. And then I apply the ag function specifying the mean to get the average. Since results are contained within a data frame, I applied the first function to turn this into a row and ask for the first value from the row. The value is already a double, so I don't need to transform it into any other data types. The resulting average value from the column uniform is 0.255. Since the table is generated by random numbers, you'll get a different value if you run this example by yourself. Now for the easy part. Fill all null values in the column uniform with its mean value. I just call the fill function, passing map as the argument, where the key is the column name uniform, and the value is the default value to fill, the computed mean for this column. To fit the results on this screen, I asked for the top 5 resulting rows only. The resulting data frame looks like this. Instead of the NaNs, row IDs 1 and 2 now have 0.255. We managed to fill all null values in a single column with its mean value. But what if I wanted to do the same for all double-typed columns at once? Let's do that in this example. First, I assign the names of all double-typed columns I want to fill to df cols. I could have done it manually, but in this example, I only have to drop the first column, that is, the ID column. Next, I drop all rows containing NaN values by specifying na.drop for the whole data frame. I then compute the average for both the uniform and normal columns, with the same group by and ag functions. There is only one row left, which means I fetch using first and then cast to an array. The result is shown in the value for df means. Now I have to build a map to be passed as an argument to the fill function. I simply zip the column names with its corresponding means and cast it as a map, which I call means map. Now for the easy part. Fill all null values in all double-typed columns with its corresponding mean values. I call the fill function with means map as an argument, and I end up with a data frame like this. Note that IDs 1 and 2 in the uniform column and IDs 1 and 3 in the normal column are now imputed with the average values we have previously derived. Another function of the data frame NA functions object is the replace function. It is used for replacing values matching specific keys. It may be performed over a single column or a subset of columns of a data frame. It also takes a map argument, where the keys are the values to be replaced and the values are the replacing values. Here we look at a simple example. I use the replace function to replace all NaN values in the column uniform with the value 0. The result of this operation performed over the dfNaN data frame looks like this. Another useful method is the drop duplicates, which is a data frame method. As its name states, it is used to remove duplicate rows, but it is possible to specify a subset of columns to check for duplicates, instead of checking the row as a whole. To illustrate this method, I append 2 more rows to the DFNAN data frame, containing identical values for both uniform and normal columns, but with different IDs. The resulting data frame, named DF duplicates, looks like this. Then I generated a list of columns I wish to remove duplicates on. In this case, the column ID is irrelevant. Hence, I create an array with column names uniform and normal by dropping the name of the first column ID. Then I call the drop duplicates method by specifying the column names array, and it drops the row with ID 11, which was identical to the row with ID 10. Having completed this lesson, you should be able to drop records and fill missing data according to different criteria and drop duplicate records.